Thanks. My name is Derek Willis. I teach at the University of Maryland. I've known Simon for a while, and I'm a old school data set user. And I just want to this is going to be a little less impressive, I suspect, in some ways than Tommy's was, and Matthias as well. But I wanted to talk a little bit about how we've used dataset, the database, in a recent reporting project we did.
I want to interrupt you for a second. We're seeing screen sharing. We're just seeing the message that says you're sharing your screen, but nothing else. So I think you might have selected the "you are sharing your screen" window as the thing to be shared.
No. Well, that's not what I want. That's what I want.
There we go. Got it. Yep, that's working. Great.
Sorry about that. All right. I want to talk about a reporting project that our students did, and that does involve dataset and involves working with LLMs, although part of what I'm eager to hear is essentially how we can make that better and easier using some of the dataset ecosystem tools. So anyway, if a member of Congress or their staff goes on a trip, it's paid for by somebody who's not a government employee or by the government itself, they have to fill out these forms. Here's a form they have to fill out. It has some information about like where they went and when and who went and how much it cost. And then it has like usually at the end or towards the end of this document, it'll have like itineraries and agendas, things like that. We get some metadata about this, but not a lot. And so we wanted to build like a database of this, which we ended up doing. We ended up building like a dataset database of 17,000 House trips and like a few thousand more Senate trips. And this database has essentially like, it's a nice relational stuff. But one of the things we wanted to do was to augment this with information from the filings themselves, which were terrible PDFs, as you just saw. The House gives us a little more metadata than the Senate does. So the House table is actually better and has more information in it, such as like who the sponsor was and where they went. The Senate doesn't do that at all. They don't have who the sponsor was or where they went. So we needed actually to extract that and then put it into that database. And giving you an idea of what that's like, here's a Senate filing. And most of them are, some of them are electronic, but most of them are image PDFs, which are lovely and terrible at the same time, but mostly terrible, right? So we ran all those through AWS's Textract, dumped the text out. And in addition to creating a data set that has like basic metadata about each trip, like you see here, we also ended up creating like a table that has all the text from Textract. We ended up using this and using dataset as then a API, as a backend, to then do some LLM stuff with where we would pass the text to a language model and then ask it to extract certain things. So to give you an example of this, from this Senate trip that was to the Software Association conference, we asked it to, for example, identify the places that they went and the reasons for going there. And to produce like JSON files. And I can talk a little bit about why we did that rather than just simply insert it into the database, but if you like, but basically we would pipe that text from the dataset API into an LLM and have it return JSON to us. And it does like a really good job. Almost every model we use, we mostly settled on using Claude, did a really good job of these things. In addition to having like where they went, we had who they met with, and additional sort of like like traveler information that was only contextual in the sense of like, did they bring a spouse or a child with them on the trip? That's on the form, but not really in a way that you could, it's like a checkbox. And so it's kind of hard to see. But the LLMs mostly did a really good job of that. To the extent that they that we ran into errors, we occasionally did, but they were mostly errors of omission rather than commission. In other words, it mostly didn't give us things that weren't in the actual travel record. It just missed a couple of things, which if you're in journalism, that's an error that you'd much rather live with than the inventing stuff, right? And so we did a bunch of stories on this, and then built using dataset as the back end, built a searchable database that folks could go in and see, essentially look at their member of Congress or at different sponsors and see, or different destinations, and navigate that database as well.
So that demo right there, is that custom dataset templates, or is that like a custom?
No, this was like a yeah, this was like using the API, and this is like a Flask joint that is baked out. It's a flat HTML.
Oh,
so
sweet.
It'll scale. Yeah. You notice like there's an index.html here, but
right.
basically all these pages are all flat pages.
Makes sense. Yeah, that's really smart.
No hosting, right? Or rather, easy hosting. But like behind the scenes of this, like to build it originally, we're calling out the API from the original.
Right. It's data set as part of a build process, but it's static at the end, so you never have to think about it ever again.
Right. That's and so like, really you get the full text of this, and then that's what's helping us along. Now, I will say, and I'll stop sharing here for a second. I will say that like what we don't do here is we're not like a soup to nuts LLM thing, the way that Tommy's showed that process. And the reason that we didn't do that this time was mostly that we had students working with us who were relatively new to programming or to Python. We teach mostly in R. And so what we wanted to make sure was that we had like a sort of verifiable steps every part of the process. Now, we could have probably built a pipeline to actually do that would have used LLM to do that, but semesters, timetables, constraints. So what we ended up doing was producing those JSON files that you saw so that we could do spot checking. We would do like take a random sample of them and like have students check them against the originals to make sure that they were accurate. And it was that part, like I said, we were really pleased with the output of this, especially given that we were shoving a decent amount of text from those filings into the large language models.
Did you experiment with any of the model? Did you try using the language models that accept images for the OCR at all, or did you go straight to TextRact?
We went straight to TextRact. We did use the image stuff for a separate project, one that involved like really horribly formatted PDFs with like attempted tabular data that wasn't really tabular, like multiple tables on a single page kind of stuff with different layouts, and that actually worked pretty well. Like the images, like that was easier than dumping the text out and asking a language model to reorganize it.
Right.
Giving it the picture of it was actually super effective. In fact, one of my students stumbled upon this by literally just taking a screenshot of it and then shoving it into a model, saying like, "Hey, figure this out." And
I've been doing a lot of experiments with that. So Google Gemini can actually take just PDFs. You can splat PDFs straight into it. But I've been doing most of my experiments where I take the PDF, turn each page into an image, and then do a separate prompt for each image, because it just feels like there's less chance of, like, if you give it 30 pages at a time, it feels much more likely to miss things. If you give it one page, maybe because of the output length limits. But yeah, I've been getting, and the results there are frustratingly close to being useful, but I don't trust it as much as TextRact. TextRact isn't going to hallucinate. That's not a thing that TextRact does.
Right. And that was the thing. Like that project involved like record books from high school sports here in Maryland, and these are just like terrible terribly formatted PDFs. And there we could afford to do it like page by page, whereas we get 17,000 travel records. I mean, you can do it for sure. But
that's the other thing, is that Gemini, the really cheap Gemini models, like Gemini 1.5 Flash 8B, will cost you a couple of dollars to do 17,000 pages of documents. And it's the results, the quality's good, but I don't know if it would survive spot checking. Like I'd try it as an experiment, but I don't know if I'd trust it without really digging into seeing what it's doing. But God, they're getting so inexpensive now. There's the new AWS Nova models that just came out in December, which are priced the same as Gemini and can do the same kinds of things as Gemini. And I don't think people have really started digging into those ones yet either.
No, that's got to be, I mean, as an academic institution, actually, it's much more easy. It's easier for us to like plug into the Amazon ecosystem because we already have like a vendor relationship there. I mean, literally we have access to Gemini now, but literally for the first year it was out, we were like, our university was like, nope, you can't use Gemini. Like
Gotcha.
literally was blocked. So, but AWS is a whole different story.
Right. And yeah, AWS Nova, if you've got AWS credentials, you have to go into their horrifying portal and click around until you find the activate button on Nova. But once you've clicked the activate button, your credentials just work and you can start running prompts through them. And yeah, they do audio and images, and I don't think they do video yet. I can't remember, but they're moving pretty quickly on that, and the prices are just absurdly low.
The last thing I want to say is we are planning on releasing the text data from this, because that is like something that nobody else has done, and making that publicly available. In fact, the whole like data set should be publicly available pretty soon. But the text is what we're really interested in seeing what people do with.
Awesome. Yeah, that feels like there's so much opportunity there.
And my GitHub, in case you want to see what else we're up to, is at is just dwillis, DWILLIS, and the same thing on Blue Sky.